Welcome to the Algebra 2 Trig Semester Exam Final Review, Chapter 2. Find the slope of a line passing through these points. You should memorize this formula. It says m equals y2 minus y1 over x2 minus x1. Some people like to label x1, y1, x2, y2, and then you just plug them in. Watch your signs here. y2 is 8 minus y1, which is 5. x2 is negative 7 minus x1, which is 1. If you're going to do this in the calculator, I've told you to use the fraction key, which is alpha y equals, and then enter. But really, it's a lot easier just to do it in your head. 8 minus 5 up top is 3. Negative 7 minus 1 on the bottom is negative 8. So negative 3/8 is your answer. Number 2 is the same thing. Find the slope. So I'm not going to rewrite the formula. I'm just going to relabel. x1, y1, x2, y2. Let's plug those in. M equals y2, which is negative 22, minus. Now watch here. It's minus, and it's a negative because it's a negative 6. The formula has a minus. Okay, and then my y1 is minus, so don't just make it 1. Then you're going to take x2, which is 13, minus 7. So negative 22 minus a negative 6 becomes negative 22 plus 6, which is going to give you negative 16 over 13 minus 7, which is 6. And when you reduce that, you get negative 8/3. Okay. This problem did not come up very well in here, so I'm just going to draw new points, and then we can talk about how you can find the slope of that line. So if I gave you this point right here, and let's see, it doesn't like when I draw dots. I'm going to try, give me just a second. There we go. Okay, let me draw a line through that for you. Okay. Here we go. Well, that's not very good. Now is it? Let's fix that. Maybe it's not going to let me. Let's see. I'm going to have to cut that. We'll try one more time. Okay, well that's better. That's as good as we're going to get. So let's pretend that's a good line, and then here are my points that it goes through. So you can do this two ways. You can actually find the coordinates of these points and write them out just like in number 1 and 2 and find the slope. Or you can remember that when we think of slope, or M, we should think of rise over run. And you always read your graphs from left to right. So to get from your leftmost point, how much do I have to go up or down to get to that right point? So to go from my left point to my right point, I actually have to go down, oh, it's making me move it. I have to go down 1, 2, and I went down. So my rise is negative 2. Your run is how much you go right or left. So from here to get to my next point, I have to go over 1, 2, 3, 4, 5, 6, 7, 8. So negative 2 over 8, and you need to reduce that, and it reduces to negative 1/4. Okay, if you need to write this down, please pause it, as I will be moving on to the next page. Number 4 says, find the domain and range of the function in the graph below. The domain says which x's get used, and the range asks which y's get used. So if I'm at 0 for my x value, and I look up or down, nothing below us obviously, nothing is there. But when I get to 1, you could see I have a value. When I get to 2, I have a value. When I get to 3, I have a value. 4, I have a value. 5, I have a value. 6, I have a value. And everywhere in between, I have a value. That's why we actually have a line, but not past 6. So my domain would start at 0 and go through to 6. Okay. Sometimes they write it in interval notation. They might write 0, 6. And because they're not open circles, you'd use brackets. They're closed. If they were open, you'd use parentheses. I am going to erase this, and we're going to do the same thing with the y values now. If I'm at 0 and I look right, I don't use anything. 10, I don't use anything. Here I start at 20. I use 30, I use 40, I use 50, and I use 60, but I don't go any higher than that. So the y values I use start at 20 and go to 60, so you might write 20 through 60, or if they want an interval notation, since they're closed circles, you can see at the ends, I use brackets 20, comma 60. Number 5 says, given the relation, find the range. The range we just talked about is simply your y values. So I'm going to write -2, 0, 6, and 8. Is the relation a function? When they're asking you about a function, you have to remember that each input, I'm just going to write in, can only have one output. I'm just going to write out. So the only way I can prove it's not a function is if I have the same input with two different outputs. So my inputs are my x's, -2, -1, 2, and 3. None of them are the same, so yes, it's a function. Let me show you what would not be a function. If I decided to add in the point -1, comma 6, this would not be a function, and let me show you why. Because I inputted -1 here and got out 0. But then I inputted -1 and got out 6. That's not a function. If I inputted -1 again and got out 0 again, that would be okay and that would be a function.